So now it's time to play. Hopefully you followed along in the last section and have started to use the Docker CLI commands. If not, that's fine, but I would highly recommend doing so in this section. This whole module is about playing around and trying different things, and that's a really good way to learn and remember what you've learned. And whilst doing so, I'm going to introduce a few additional concepts. For example, mapping ports so that we can actually use the containers that we're spinning up. We'll also look at getting a shell CLI inside your containers. We'll talk about image tags and more. And lastly, we'll end this module by just spinning up a few different arbitrary containers from third-party Docker Hub images, just to really show how easy it is to spin up third-party software in Docker without actually installing both it and its dependencies on your machine. We now know how to spin up containers from images, but we haven't actually done anything with them yet. So if we go to this command we did in the previous section, docker run nginx, spin up a container, go to the browser and go to localhost, then nothing actually happens at this point. The reason for this is because we're not publishing any ports yet. Now docker run has a command line argument, -p. It actually stands for publish. I find it easier to think about it as port, but basically what this does is it publishes the container's port to the host. And the number to the left of the colon is the port number we're going to access it from outside the container. The number to the right is the port inside the container that the software is listening to. So nginx by default listens to port 80. So if we run this container now, and then go back to the browser and F5, then we've got nginx, and we've got a log at the bottom so we can actually see the request coming into the container too. To take this example a bit further, if we stop this container now, spin up a new one but specify a different port number, 1234, run it again, go back to the browser, F5, it stopped working on port 80, we can go to 1234, and now we've got nginx again. Another thing that's worth pointing out is you can specify -p multiple times. So in this example, RabbitMQ, 5672 is the port that your software would do publish and subscribe to, so it's the AMQP protocol. The 15672 is the web user interface for RabbitMQ, and here we're specifying both. So if I run this now, and then go to the browser, change the port for the first number, we should see an error. So this is totally expected because I'm using an HTTP request to access AMQP endpoint, which is a different protocol. But the fact that we're seeing this error in the container output means our traffic is hitting the container, which is kind of a good thing. That means the -p is working. If we change the port number to 15672, then we can now access the RabbitMQ portal. So we can now see that we've just published two different ports from the same container to the host machine, so we can access it. Let's go back to our faithful docker run command. Ignore the fact I'm using nginx again. The image doesn't matter for this demonstration. When we run this, we've got the logs, but note the fact that this completely takes over my terminal. I can go to another terminal and do docker ps. I can see that container running. I can do things to it. So for example, if I do docker rm, so that's remove, -f means that I can remove a running container, otherwise it would fail. And then the container ID. It's worth noting that whenever you specify a container ID, you only have to specify the first few characters. So that's removed it. If we docker ps, it's gone. If we go to the other tab, we can see it's being killed. However, what if we just want to run the container in the background, fire and forget? We don't want it to take over the terminal. So that's where detach mode comes in. There's another command line argument, -d or --detached. That's the full version. And if you add this, then straight away it's just run the container in the background. It's dumped out the container ID, but that's it. If we do docker ps, then we can see it is running. It's just a very quick way to run it in the background. We can still interact with it. So if we do want to see the logs, there's a command called docker logs, and that's dumped out the logs here. Notice how that it's actually dumped them out and exited again. So I've got the terminal back. If you want to follow, if you do docker logs. Now remember at the start how I said that you can use --help, and that will give you more information about a specific command. So in this case, logs, and we've got this information, so we can do -f for follow, -n to get just the last number of logs. We can get the timestamps. So if we try and follow it now with docker logs -f, so we've got the logs, but we've not got the terminal back. So if we get more logs coming through, we'll see it here. If I control C to exit this, then we've not exited our container. Just running docker run without -d, control C would have exited the container. So we can see it's still running here. Another command is docker attach, and this reattaches to the container in the same way as if you've run docker run without the -d. So this hasn't done anything because we need more logs. If I go back to the browser and type localhost, so we're accessing Nginx, then we can see we've got some logs now. So this is just as if you hadn't done -d in the first place. So you can see that we've got a few different options when you're running docker run. You can run it in the background, you can run it in the foreground. If it's in the background, you can inspect logs still, you've not lost it, and you can still use the Docker CLI to interact with those containers. In this section, we're going to get a shell in a running container and play around, just make a few changes, because this will give us a bit of a better understanding of how this works and fits together. So by now you should be familiar with this command, docker run, -d detached, so runs in the background like we saw in the last section, -p, so this is specifying the port number that we're going to access our container on, and then we're going to use Nginx image again. If we go to the browser, we can see that localhost isn't working. We run the image and straight away we can see we've got Nginx running, so it's really that fast. Then if we do docker ps, we can see that we've got our container running. Now, if we want to get a shell in the container, we're going to use a command called docker exec. And with this, you typically use the argument it, so interactive terminal. T actually stands for TTY, but it basically means terminal. So think of it as interactive terminal. Then you specify the container ID that you want to run the command in. So remember that you only have to do the first 3 characters, not the full thing. Then you specify the command you want to run. So you could do bash, you could do another command like let's try ls, and then we can see, if we run this, we can see the output of that command. We could do like pwd or something, get the current directory. If you just want to get a shell though, you'd use like bash. Some images might use the sh shell rather than the full bash shell, but most of the time bash will work. If bash doesn't work, then try sh. But Nginx is based on bash, so we can do that. And now we've got a shell. So what we're going to do, we're going to have a little play around. We're going to change the HTML file inside this container, this running container. So Nginx stores its HTML files in user shared Nginx HTML. And then if we do ls, we can see we've got index.html. So this is what we're going to change. Now this Nginx image, because obviously they want it quite lightweight, doesn't include a text editor. So this is another good point. This is Linux, so I can just do like apt-get. I need to update to get the very latest repository information, and then apt-get install -y, and then my editor, Vim. So this is now installing Vim inside this container. I can now use it, and inside the container I've installed Vim and I'm using it so I can modify this HTML file. So what we're going to do, we're going to strip out all this, and then let's just put hello Dome Train. Now if we bring up the browser and refresh, we've got hello Dome Train. So it's important to note that I've only changed that container, and remember that a container is a running instance of an image. So we've not affected any other containers, we've not affected the image, we've just changed that one container. So now what we're going to do is spin up another container from the same image. So let's use port 1234. So if we do docker ps now, we can see we've got 2 containers based off the same image, Nginx. If we go back to the browser now and open up a new tab and go to localhost that 1234, we can see that that doesn't have our changes in because it's a brand new container. Another thing I want to show, and this is typically not how you'd go about creating images, I just want to show it for completeness, is there's a command called docker commit. And what this does is it allows you to create an image off an existing container. You wouldn't typically do this. I'll show later how you create images using Docker files. But for completeness, I just want to show that we can do this. So if we run docker commit, I'm going to specify the container ID. Now this is the container ID of the one we changed. Give it an image name of something else, so Nginx modified, it could be anything. And then we've now got a new image on our computer. We've not done anything with it. We could push it to an image registry, but at the moment we've just got it locally. Now if I create another container from this image, let's give it like 1, 2, 3, 4, 5. So we've now got 3 containers. So if I open up the browser, our first container still contains our changes. The second one doesn't contain our changes. If we duplicate this and go to 1, 2, 3, 5 now, remember this is a brand new container, but it's based off our saved image, this Nginx modified. So that does have our changes in. So if we do Docker PS again, we can see we've got our 3 containers. It's ordered descending, so the one at the bottom is the one we created first that we modified. The next one up is the one that we recreated, which is like starting from scratch. We haven't modified that. And then the next one up, you can see that it says image Nginx modified is the new container we created from our image we saved. Hopefully that makes sense, but as I say, you very rarely would use this docker commit command. I just wanted to show that you can do this. Later on in the course, we'll show how normally you would create Docker images.